But what I want to do with, and you can go to the next slide if you want, if you look to the numbers that we achieved, in terms of 51% being the revenue, 51% of the revenue that we make in digital printing currently being labels and packaging. I want to talk a bit about what's the background and where does it all come from. And I think you probably know the Xeikon 3000 series quite well. They were actually the basis in 2008, when we started with them, of the success, I think. Having the flexibility of having entry machines with an affordable investment cost, but at the same time having also very high productive machines, and between them having the flexibility of upgrading upgrading from entry machines to the high-end machines. And at the end, it's also a very broad portfolio. I mean, today it's still even the biggest, with these 5 machines, the biggest portfolio that exists in labels and packaging at one supplier. If you look, for example, if you look to the inkjet players, the majority of them are playing here in the high end, in the high-speed environment, but they don't have any entry models. So that restricts, to a certain extent, their reach into the market. But if you look now a bit further from we have this 3000 series, how did actually, where does the business come from with this 3000 series? Well, in essence, these machines are sold into four applications specifically, or actually more than 4, but these are the main ones within labels and packaging, being the self-adhesive, folding carton, IML, and heat transfer. And if we look to the machine sales, then you will see that actually 20%, a little bit less than 20% of the sales is happening in the white web environment. So we're talking here about the print engines, the 3050, the 3500, or even upgrades to a wider web kit. That represents around about 20% of the sales, which is evenly distributed over these 4 applications. So there are even self-adhesive label guys that are buying these white web machines for the reason that it increases their efficiency, it also reduces their costs. And so, for example, if you look into the food market where price is always a topic, and where volumes are quite high, the self-adhesive label guys, those are areas where they would look at. Or if you look to industrial labels, like for example the oil canisters or big health and beauty labels, there is again customers that invest in such kind of equipment. And some even see it as different shapes. So people that, for example, today have already alternative digital technology at, for example, a Xeikon, because of its 20-inch capability, the 500mm capability. The folding carton market is predominantly looking into that 20-inch, same as the IML, and same also as the heat transfer. Although I have to say that actually it's almost 2/3 of the heat transfer machines that we sell that buy the white web, and that's mainly heat transfer for the industrial environment. So talking about the decoration of plastic containers, such as buckets, for example. And the other third is actually buying the narrow web machines, but that's more heat transfer, like you have here in the UK, diamond photofoil. They are decorating, for example, pens or soap dispensers or ice buckets, all type of promotional articles rather than industrial parts. So this is a bit of an overview of where the sales goes in terms of web kit capability. If you look from the other point of view, and we have a look to what kind of machines are being sold in terms of productivity, then the split is more or less 50-50. Although this graph shows 45-55, I would have to say that it's actually 50% is actually people that are buying a 3500 or 3300, which are the high-end machines, the high volume machines. And that remaining 5% is actually an upgrade of people that bought an entry machine and are either upgrading by width or upgrading by speed. So it shows really that the portfolio of the 3000 series, that matrix that we have of entry machines and the high-end productivity machines, that actually appeals very well to the market. So you have printers that indeed buy an entry press and from there grow further, or you have people that really have the capacity and start off with a high-end productivity, or high productivity machine from the start. Now, the thing to move forward, we are clearly for sure the number 2 in the market of digital labels and packaging. The only way to move forward is by innovation. That's the only way how you can stay on at that level. Certainly in a market that is changing so fast. So, and if you're innovating, if you want to innovate, well, then you have to look also into how do we do this? I mean, we can do it in our own room, or you can actually talk with the market, with our customers, or with specifically with digital label printers actually, but also with the team that we have now, our own sales team, and our dedicated dealers and agents in certain areas that are very much experienced into the market of labels and packaging. So we use them a bit as a soundboard to understand from where is which direction do we have to go. And there's always a few topics that come up, as we've indicated already, from people are asking from should we look into alternative technology? There's a lot of inkjet technology coming to the market. Should we look into that as well? Maybe we should expand actually our color gamut. Maybe we are currently using or selling machines with 5 printing stations. Maybe we want to have more printing stations. Maybe we have to increase speed. But a sure thing, we have to look into reducing production costs. That's a sure thing. So what we did is we for the past years we've been talking at certain occasions with people and customers about this to get an understanding and to create actually our own strategy. And what I want to do now in the next slides is I want to share a bit our thought process, how we came to the point of how we came actually to make a selection of these various options that are there. First of all, if we ask people, I mean, you can talk about looking to alternative printing technology, but then at the same time we asked also from, okay, what kind of quality actually do you expect that a digital printing press would have to deliver? And the clear answer that we got there is that the quality from Xeikon is the minimum. We don't want to go below the quality from Xeikon press. That's the basic quality. If it's better, that's fine. But if you bring out innovation and you reduce the quality, then there is no interest for at least for the people that we were talking to, specifically the customers that we're talking to. And if you actually look to that, what happens is that actually in the digital printing market, that today the benchmark is indeed quality work. I mean, 80% or more than 80% of the volume is actually done on electrophotography, being 2 suppliers, being the people from Israel and ourselves. Besides that, you also see that there's a lot of applications where digital printing is used for, like the wines and the spirits, but also the food, which is, I think, representing 40% of all representing 40% of the volume that is printed digitally is for food applications. You'll see that these are really labels and packaging that require really high quality. There are other markets, like in the industrial labels, where it's less of a topic. Health and beauty to a certain extent also a bit less. But really in the wine and spirits, that's where they really want to have good quality. If you look actually to the developments in the conventional market, then you see also there that the developments that are taking place there is driven towards higher quality. Specifically for the companies that are involved with or can influence the image quality. If you look, for example, to the press manufacturers, they're focusing on shorter web paths, lesser energy, quicker setup times. But if you look to the people that have an impact on image quality, being the companies that produce the imaging technology, like ourselves with our Thermoflex, but also the Kodak and the Escos, I mean, they're talking about HD Flexo. Kodak is talking about their flat top dot technology. Well, it's all about how do we increase quality because they see a potential here to take more volume away from gravure or either from offset printing. So these are the two trends that you see, and it actually supports a bit also from, I mean, if we talk to guys and they say to us, yeah, the Xeikon quality is the minimum we don't want to go lower quality, you see also other trends in the market or things that confirm that indeed quality is an aspect that you have to maintain and you have to nurture. Now, taking that into account, we look into from, okay, is there then an alternative technology that we could look into that still maintains the same quality? And then we try to analyze a bit from, okay, what is actually quality? And this week earlier we had indeed a discussion about in America what is quality. Is quality 7 colors? Is quality about the fineness in dots that you can print? What is really, how you really define quality? Well, when we talk about quality, we really talk about the dot definitions. If you look to digital printing, the area where digital printing makes sense is in full color printing. Now, full color printing, how does it translate? As soon as you get graphics into a design, as soon as you get multicolors into a design, then you come into a challenging area for the conventional printing systems. Conventional being that if you do a full color graphic, then you require multiple plates. Per plate you need to adjust your density, you need to adjust your registration. That creates a tremendous setup time. That setup time is where digital provides a big benefit. If you look to conventional printing, where it's only one color or two color printing or three color printing, it's most of the time a specific spot color, lesser plates. Density doesn't have to be adjusted because they run actually with a specific spot color. So there's going to be less waste, so the startup cost is less. So if you run only 1, 2, 3 spot colors, the competitive advantage from the digital compared to that is very limited. But if you go into the full color area, that is where digital has a big advantage because you reduce your setup times, you have minimum amount of waste compared to what conventional has. So indeed in full colors, the big challenge there is then that you are, to achieve a good quality, is to make sure that for the different color planes that you have, minimum 4, being C and YK, that in such kind of, that during the printing that you maintain actually the size of your dot, the shape of your dot, and that is consistent. That the positioning of your dot is very accurate and also consistent, because otherwise you will have color variations or have an impression that indeed the quality is not, like the image is not presenting itself. And that dot consistency is something that is from one technology to the other technology can be very challenging. And when we, for example, then compare two technologies, specifically electrophotography and inkjet, then there's one specific thing, and sometimes you have to simplify things to make a decision. You can make the biggest mathematical formulation to come to a decision, but sometimes you have to just look to the basics. And if you look here, what I try to do here in this graph, in this figure here on the right side, on your right side, you have here the substrate. That's that gray, the gray bar there. And what you have here is actually on this side is where you have the imaging station. In case of an inkjet, it's actually a jetting head. In case of electrophotography, let it be dry toner or low viscosity toner or liquid toner, that actually is an imaging drum. Well, the distance that a dot has to travel within an electrophotographic system, using dry toner or liquid toner, the distance that a dot has to travel from the imaging drum towards the substrate is just 200 microns. So being able to provide a consistent positioning of your dots is tremendously easy, or 10 times easier actually, or actually only 8 times easier if you look to the distance, but it's much easier than with other technologies. Because if you look, for example, to inkjet, your positioning of your head there is actually 1.5 millimeter from the substrate. Now, when the dot, from the point where you actually jet your dot towards the substrate, when that dot is traveling that distance, there are a lot of parameters that can influence how it will eventually end up on the substrate. I mean, there is airflow in this area here. The substrate can vary in thickness also, which any substrate does. On top of that, dots have various sizes, so are different in size. So that means if we have a smaller dot compared to a bigger dot, the impact on the substrate will be different, which will influence also your dot size. So therefore we see that there's much more challenges here to achieve ever a quality related to dot positioning and dot consistency than there is actually with liquid toner and dry toner. So from that perspective, we said there's going to be a lot of challenges, a lot of development required to even get consistent. And the question is if you will ever get it consistent, because you're actually depending a lot of parameters that you don't control yourself. On top of that, if you then look to the benefits that, for example, a dry toner has compared to an inkjet, we actually at the end concluded that that the potential there for us, or the advantage, the competitive advantage we would get by going into the inkjet environment would be very limited. Even if you look to today, the volume that, as Wim indicated already, the volume and the value that the market that is today addressed by inkjet is representing, and how many players are trying to fight for that bone. I mean, it is for us, it would be actually, as a company, it would be a distraction rather than a benefit and a focus and an ability to drive actually the market of labels and packaging further. So therefore, when we looked actually into alternative technologies, we clearly indicated that that on the inkjet aspect today, we don't see a value to use that technology in the full color printing environment. So we're going to further develop the dry toner, and maybe over time, even for the full color digital printing, use also over time, maybe in the further future, also the liquid toner. A second thing what we did then is, or another question that was alive, is the question about the color gamut. Do you need more printing stations than you have today? Today we have 5. A very difficult question, because color is a very sensitive topic to discuss all the time, and everybody has different understandings or opinions about it, and the right opinion doesn't exist. So what we did in this case, throughout the time, I think we spoke to 20%, we spoke to printers, of which 20% were actually digital-only printers, and 80% were printers that had actually a conventional background and acquired the digital press, or the other way around, started with digital press and then moved into the conventional. So, and we actually got different answers from the people if we talk to them. So if you look to the guys that were only doing digital printing, which was representing more or less 20%, and we asked them from, do you need a bigger color gamut? Is that really something what you're looking for? Then their simple answer was from, well, I don't know, we never get complaints with color. And you think by yourself, how can it be? I mean, if you talk to the conventional guys, it's the biggest topic they always talk about. The color needs to be accurate to this. But these people, I mean, when you're a digital only guy, what they do is they get a file from the end user, they print it, and they maybe have a discussion about the delivery terms, they maybe have a discussion about the price, but never about color. Because it's not something that they have in their mind. Sometimes you trigger also reactions from your print buyer, because you want to anticipate for certain complaints or certain comments. With digital printers, most of the time, what they say is that we just get the work that we get, we print, and people, they are happy with what they get back, because there's never a demand or any specific request towards color matching type stuff. What they do see is that they frequently come up with questions from, can we print silver, can we print gold, special kind of colors. Not really colors to expand the gamut, but really colors to make specific aesthetic features into the designs. Now, if we look then to the other part of the printers that we talked to, then we got a total different answer. And I tried to put it politically correct in the sense of that their answer was more that color matching is really something that requires a lot of attention, where they really have to spend a lot of time on. And if you look to the reasons behind that, well, then you see that as soon as they start working with digital printing, after a while they start to realize we're never matching a color. And indeed, in digital, it doesn't matter what technology you have, you will never match a color. You will always simulate the color. You will try to match a color. And sometimes it's very good, but sometimes not so good, but you will never match a color. It's always simulating. You try to achieve a certain color that is defined in your in the prepressed file. On the other side, what these conventional guys experience, or what it actually most of the time exposes themselves to, is the fact that they start to realize that what they thought they had a color management strategy, is in essence something that they actually didn't implement properly. In the sense that they still do all their color management on their plates, and then finally the plates come to the press, and at the press itself they still tweak and tune the color, or they still tweak the colors to match actually the desire of the customer. If that is indeed the process that you have in your factory, well then you don't have color management implemented. You don't have a color management strategy. If you really have a proper color management strategy implemented, then you can rely on it that what the prepress guy does is also the end result that you achieve on your flexo machine or on your offset machine. So, and a lot of it takes a while. It's certainly not in the first week. After 6 months, after a year, these conventional guys start to realize from shit, the strategy, we simply don't have a color management strategy in the house. So, and therefore it's a big learning curve for them also to, and we try to help them with that, is that we try to illustrate that the backbone from actually a good color management strategy is to ensure that the expectations from the end user, from the sales guy, from the managing director, production director, and the print operator, and the pre-press guys, that the expectations of those 6 people are all aligned. And when you have an alignment there, then you can build further on or implement a color strategy into your company. If you don't align them, the printer will always do the right thing, and the pre-press guy will always do the right thing, and the sales guy will always do the right thing, but at the end they all have different expectations, and you will never match it. So you need to make sure that you first align the expectations there. You do that by indicating what the press capability is and communicate that to others. Provide also tools, for example, to the sales guy that they can illustrate to from, look, if you ask us to reproduce or print this file that contains all these Pantone colors or HKS colors in Germany, then, well, this is how it will look like. Create an expectation in the beginning rather than having to fight afterwards for it. So this is something where we see that a lot of the conventional guys are fighting with, actually. And where they go through a certain process after they've required a digital process. One thing that they do confirm is that as soon as they printed a job on digital, as soon as they met the expectations of the customer from a color perspective, it's damn easy to reproduce it. Compared to a conventional machine, it is 10 times easier to reproduce and hit the same color over and over and over again. Again, when you put all the right production procedures in place. But it's much easier than what you would have with the conventional process. Yeah. So also there, if you in the first conversation and you ask them, do you want a bigger color gamut? Yes, I need to have a bigger color gamut because I can't match all my colors. But if you dive a bit deeper into the reasoning behind it or the challenge behind it, it's most of the time not a lack of color gamut, but it's a lack of color management strategy within a company. And actually, if we look a bit further into our own business, I mean, Xeikon has been offering spot colors to the market, or the capability of buying spot colors, but also the capability of buying gamut extension colors. We have a printing press that has actually 5 printing stations, so you can indeed extend the gamut from CMYK to, for example, CMYK and orange or CMYK and red to extend the gamut in a certain area, or to put certain colors in there. But when we look to actually the volume of toner that we sell in the labels and packaging, well, 96% of that is CMYK. 2% is white, which is a substantial amount. That relates to printing on metallics, relates to printing on onto transparent materials. And the other 2% is represented by a great variety of different colors that we have available. And you see that it's growing, as also our volume is growing. And that there are certain colors that stick out. For example, the orange here. And this orange bar is also reflecting the volume that is being done with the orange toner, the orange spot color toner. But this is, for example, something that I expect is going to drop. Why is that? You have all the new regulations for, I think it's global harmonization regulation there for the warning signs that you have on chemical labels. In the past, there was defined that the color that you used there was a specific Pantone 21. It's a specific orange for the warning signs. But the new legislations, they define now that the pictograms are totally different. So the orange is gone, now it's red. And they even made it much easier. The red is not defined as a Pantone color anymore. You could use actually any kind of red. So the red that you can reproduce out of CMYK will be the one that people will start using. So I expect actually that where today a lot of that orange is still being used in that environment, that is going to drop as these new regulations are implemented. And the other color that is quite big is maybe here the extra magenta. But the extra magenta is in our case a color, and when I'm talking about big, it is still a fairly small percentage compared to the others. But for example, why are people using the extra magenta? Is because inside the magenta pigments, or you have certain applications that, for example, have a prescription that is say from the toners or the inks cannot contain halogens. Certain chemical construction that can't be in there. Specifically in Asia, they have that request, I think, for electronics type of work, or electronic labels. And a standard magenta pigment contains that. The CNY, sorry, the yellow, the cyan, and the black not, but the magenta does. So you need to go to very special pigments, which the extra magenta is. that complies with such kind of regulations. So that's why those are two colors actually that today are fairly, represent some of the bigger part of that small 2%, but by then even I expect that the orange is actually going to drop. So if we look to how digital printers are looking at it, a pure digital print is saying from, well, color gamut, I mean, from our point of view, we get the file we printed and the color is white from their perspective. If you look to conventional guys, they say, yeah, okay, it is sometimes challenging, but it's more to do with our color strategy. And yes, we have to accept that there's a color gamut, but is there really a need to go to bigger gamuts? Because on the other side, it makes it more so expensive. And the third thing, when we look into the usage of the toner that we've been offering for the past 6 years, is very limited. So therefore, we conclude from our point of view that, let's say, if we would build a machine that could do 6 colors or 7 colors or 10 colors, it has an advantage, but it's really so compelling. We didn't think, from the research we did here, from the conversations we had with people, we thought that yes, the spot colors or having a bigger gamut is nice, but having more printing stations is also nice. But it's not going to be the one that is going to differentiate ourselves or even allow our customers to differentiate themselves from others. So the other question we asked was, is there then a need for speed? Should we make machines that are more productive? And what you do see is that if you look to the overall growth in digital printing, there is from volume perspective, there's an overall growth of a little bit less than 18%, a little bit less than 20%. I think precisely it would be 18.9. That's the estimate from Infotrends. And what we see in our customer base is that actually there's more customers that are adding actually additional machines. They start up with one, do an upgrade, and then add an additional machine. And on the other side, to make these customers grow also, they are also looking into how can we optimize our production costs. But if you talk about optimizing production costs, then then we can actually have a look from where are production costs based on. And in essence, production costs are based on 3 parameters, 3 main factors. One being the print media, but if you want to reduce your costs on print media, that's purely doing good price negotiation. Or you can use cheaper materials from somewhere else, but again, it's related to the price of your substrate. If you look then to the consumable cost that is being used in digital printing, well, there it could be a price negotiation to make sure that you buy indeed the consumable at a favorable rate. And next to that, it's also depending on what kind of business model you go in for. If you go for a click or if you go for an a la carte model where you just buy what you consume, where it comes down to having a good press maintenance. If you have a good maintenance of your machine, that you can extend lifetime of components, and it's only pure extra profit for your own pocket. But another factor, the third parameter that contributes to cost is actually the fixed costs. So the depreciation of your machine, the investment that you've made, the operators that are handling the machine, the overhead that you have for the building, for the electricity, all those type of aspects. And in that formulation, there's also one parameter being speed. And that is one that we can influence very strongly if we would make actually a machine that is faster. Productivity is part of speed, but it also relates to, for example, what kind of jobs you're putting onto the machine, or how you organize your whole organization. So, but certainly speed is there, an area where we can have an impact. And on top of that, until recently, the Xeikon 3300 and 3500 were actually 30% slower than in pure speed. If you look to the pure speed, not the productivity, but if you look to pure speed, then these the 3300 and 3500 were 30% slower than the other competitor from Israel. So taking these things into account, we said actually that if we would make a newer machine that has higher speed, that would be indeed the area where we are going to make the difference then. And that's where we came up with Cheetah, the animal that sits on at the table also with you. Very nice little kitty that brings a lot of differentiation. This is some examples of, since Label Expo, a kitty that has been very alive on the social media also, with very recent pictures. This is the last one, I think, that was taken this week. Visiting Xeikon, one of our customers in Orlando, in Florida. where we had also this press conference together with the North American people. But what is actually Cheetah? What is the product? It's actually a product that we designed specifically for the self-adhesive label market. In the beginning I talked a bit about and Patrick will talk more further about it in the applications we serve. We have the self-adhesive labels, the IML labels, the heat transfer and the folding carton. Again, the success of is depending on how much again you focus with your product. In this case we were very clear. If you look to the volume that is today being produced in labels, in self-adhesive labels, if you look to the growth that we experience, or that our customers also experience in the self-adhesive labels, then we really need to make something for them. And this press afterwards also be used in other applications, maybe, but today the main focus of the development is around self-adhesive. And we designed also the specifications in that direction. The press itself provides the highest quality with the highest speed. So we don't want to be in the mediocre quality range. It is the fastest and most productive solution in its quality class. The fact that we use the dry toner, it's also the most food safe technology that you can find. There's simply no components that can migrate because it's a dry process. It's more than 50% faster than the existing model, so it's not like just a minor step forward. It's been, I think, in the last 15 years, the biggest step that we've ever made actually in the area of dry toner. If you look to the concrete specifications, this press runs actually 30 meters per minute, 5 colors, 1200 dpi. And that speed is not impacted by the resolution. So sometimes people ask me if I would print 600 dpi, does it then go faster? No. That's relevant for inkjet technology, not relevant for Xeikon technology, because we use LED writing it. So there's no impact from resolution. There is no impact from the size of the label, and that has to do with the fact that we're full rotary and a variable repeat length. Neither is there an impact from the amount of colors you use. If you use 4 colors, 5 colors, or 4 colors plus white, the speed will always be the same. Which is for a business owner very attractive, because you know if I switch on the machine for an hour, then I know how much meters I print, and then it allows you to make your costing very easy as well. And a parameter that specification that shows very clearly that this is a press designed for the self-adhesive label market is actually the web width. You see that we go from 200 up to 330 millimeter web width, and that is really the market for the self-adhesive label machines. So, and how does then the whole portfolio change? Well, in essence, what we're doing, the 5 machines that we had so far are now extended actually with the Cheetah, being a press that that provides here at 98 feet or 30 meters per minute, and with the same web width capabilities as the previous machines, being the Xeikon 3030, 3030 Plus, and the 3300. One thing that we do have to give up is actually that there's no upgradability towards the Cheetah. So there's an upgrade path here amongst the 3000 series, but not towards the Cheetah. It would be indeed a forklift upgrade. The reason for is that there are specific hardware developments that were required. And I'd like to give you a bit of an overview of what kind of developments it had required or that were needed to do this. So what you see is actually a cut through of the Xeikon press. Within the Xeikon press, you have several sections, several locations where technology is being used. So you have a printing station. Around that printing station, you have charging heads and writing heads and ink application and transfer. So that's always a process that has to be looked at more in depth if we go for higher speed. Are there restrictions, yes or no? Then there's also the fusing section, and I will go step by step actually to look into the various processes to understand from were they a barrier, were they a bottleneck to go for higher speed. The first thing we looked at, for example, was the writing head technology. So that's per printing station that's valid. Actually, that's a module that sits here at this location around the print station. And what we looked at is from, okay, how fast can actually the writing technology that we're using an LED bar, not a laser like others, or no jetting heads like with inkjet. So we're using an LED bar, and we verified from how fast can this actually go. And it's not about the lights, the LEDs that go on and off. It's about the data, the image data that you can actually send to that writing head, and the writing head that can translate it into an image that it exposes to on the imaging drum. Well, in that case, we've verified that the writing heads that we have today, the 1200 dpi writing heads that we have today, they can go up to 90 meters per minute. So there's no barrier there. If we look further, we said from okay, we can go up to 90 meters, but how good is our xerographic process, our electrophotographic process still working? And what we saw there is that there was actually a lack of charging. If you know how the xerographic process works, it's actually a photoconductive drum that contains an electrostatic charge. Is then discharged by the light that might be exposed to by lighting it. There where it's discharged, your toner will develop and then it will come to the substrate transfer and go to the next printing station. But what we noticed is actually that the amount of charging power that we had in the printing stations were not sufficient enough. So that is one of the specific areas where we had to do development to create a Cheetah. And this is one of the, sometimes if you open a machine and you compare a 3303 and a Cheetah, you would think from there's no difference, but if I point out, you can clearly see that indeed there has been developments because we had to implement additional coronas there. The other area where we looked at is actually into the developer unit. Because okay, you can run at that speed, you have got the right charging, but can we actually at that speed, 50% faster, still distribute sufficient amount of toner into the developer unit, so that we keep a very even and well distributed image quality across the web. And that is where we have identified again that the developer unit that we had was sufficient enough to cope with to work within the specifications that we have. Another area is from, well, you go here again 50% faster, so that fusing section where we are using heat to melt the toner to the substrate, that fusing section has to actually process 50% more material in the same time. So you have to have either increased temperatures or you have to do something to be able to cope with that. And this is where there was a big breakthrough for us last year, the ice technology, or the ice toner that we had also for the 3300. Well, that technology, which actually exists out of utilizing new polymers that have actually a lowering melting temperature. So what we in essence did is, we took a toner particle, we opened it up, took the existing toner, the existing polyester particles that are sitting in there out, and put in other polyester particles that actually have a lower melting temperature, and by that creating actually a toner that melts at a lower temperature. Well, that ice technology is what we used actually for making this process work. Now, we're not using the standard ice toner that is being used on the 3000 series. Why not? Because what we noticed is that the time that the toner sits in such kind of a developer unit is shorter. If you run at 50% lower, then the time you add toner into it, and then the toner will be in there for a while until it's consumed. That depends also on coverage, on how much toner you're consuming per design, for example. But here we saw that actually the time was much shorter compared to the 3000 series. So we had to actually change some of the components that were sitting, the raw material components that are sitting inside the toner. And by doing that, we also saw that there was a need to reduce actually the toner particle size. And by doing these exercises, we made actually what today we call the Cheetah toner, which is based upon ice technology, but still is a toner particle that is a bit smaller and uses some different ingredients that fits actually with the productivity that we have here. Unfortunately, it's not a technology that we can downgrade towards our existing 3000 series, because the change that we made into the raw materials is purely to do with the time that the toner sits inside the developer unit. Now, the fact that we had to make a newer toner and the fact that we used different raw materials, but specifically because the size is a bit smaller, and the toner particle is not a 2D particle, it's a 3D particle, so that means if you make the size a bit smaller, it's the amount of raw materials that you require to make it reduces also, and that's to the power of 3. So in essence, we're making this toner we use less raw materials, so we're actually making this toner cheaper. And the production cost for this toner is cheaper. And we could be sneaky Belgian guys and say, that's good to put it in our pocket, but on the other side we said we want to give something back to the industry as well. So the toner, the Cheetah toner specifically, is also, because of the fact that its production cost is less, the list price or the commercial price of that toner is also less compared to the QAI. Alright, so we got our print stations, we got our fusing section here.
What proportion?
10%. Then there's another aspect, of course, and that's maybe the easiest one, or easiest one that you can think of. If a machine goes faster, it also relates to do the motors have the capability, does the web drive have the capability to run at such kind of speed? And that was quickly that we noticed that indeed the motors were simply too weak to cope with that kind of web width and to maintain also the web width to cope with that kind of web speed and to maintain the web speed very stable. So that is also an area where, if you look to the Cheetah, we had to do specific changes to change actually the complete new web drive and change all the motors. So those were the three main areas where we actually see that development have taken place for the Cheetah, and where we see in other areas there is even opportunity or other areas which might be considered as potential bottlenecks, that there is still a lot of latitude to go into the future. Now, if you take all these things into account and then you look to the costing of a Cheetah compared to a current 3300 series, then you see actually that overall there is a cost reduction of 10%. Now, where does it relate to? So what I did here is we made a calculation of one shift operation that, and we look here into a specific label design. I mean, the machines have the same imaging web widths, printing web widths. But if you then make a comparison between those two, then you see that actually from substrate cost there will not be any difference. When we use the same material to make the comparison. Where will the big difference be? Is in your fixed costs. That is, of course, your investment, but also your operators that are there, where you're actually having a higher efficiency from your operators because you're producing 50% more. So you have a very, very nice drop here in the fixed costs per linear meter or per square meter. And then there is, of course, a drop in the consumable cost because of the fact that the Cheetah toner is less priced compared to the QAI toner. Overall, if you look to, and that's just like an Excel calculation, that's very simple. In real life, with the production facilities, they can even more optimize these costs more. But simply from a simple calculation, you can see that actually you get actually a 10% cost reduction by printing actually on a Cheetah platform compared to a 3300 platform. Okay, now this is giving you some ideas on the advantage where the Cheetah positions itself over the current portfolio. Looking a bit to the competitive landscape, we also try to give you an idea here. What you see in this graph is actually the various printing models. So here is what we call, you have a 3-color mode. Some people name that also as an enhanced productivity mode. You have the 4-color mode. You have the 5-color mode, where you use 5 printing stations. And then you have the 4-color mode, where in the 5th station you use white. And in certain technologies, to achieve an opaque white, they have to do multiple passes. And that's purely related to the basics of technology. Dry toner compared to liquid toner. And that has an impact, a negative impact on their productivity as well. In this case, we're only comparing the machines that are 330 millimeter wide, or 13 inch, just for simplicity. And we have the 2 other technologies that are using liquid toner. There are 2 presses that are using liquid toner. We have R3030, 3300, 3030 plus, and the Cheetah. This purple line here, that is the Xeikon 3030. This pink line is actually the Xeikon 3030 plus. The bluish line here is actually the 3300, and the green line is our Cheetah. And you can recognize the Xeikons very easy. Why? Because based upon this technology, we know that the productivity of a Xeikon, independent of the color mode that you are running in, is always constant. If I would be putting here 6 colors, of course that's not feasible on Xeikon, that's why I put it up there. The other presses would be able to do that, but we only look to the areas that are feasible on the Xeikon press. But you see there that the productivity is constant throughout those different color configurations. What did we put here on this side is actually the amount of square meters per hour. So we put the productivity of the press here. And then you see with the here that, okay, in a 3-color mode, The high-end system of our competition is a bit faster still there. But as soon as you go to a 4-color mode, then at that point we are providing already a 12% higher productivity. If you go to a 5-color mode, then you see that we're having already 4% more productivity. And if you go to a 4-color plus white, then you see that we have more than 60% higher productivity than what our competition is offering today. Even a 3300 runs in that configuration already faster. And this is purely comparing speed to speed. So we're not taking into account any uptimes here, because if you would put uptimes into perspective, the people that use various technologies alongside each other, I mean, they will verify to you that the Xeikon is one of the most reliable presses in the digital printing arena. So that would even up the R scale as well. But here is purely theoretically looking to the meters per minute that this press runs, translated to the square meters that they run. So this is, if you look from the Cheetah here, where we're talking about, this is the fastest digital press in the league that we're playing, in the quality class that we're playing, because we do get comments from inkjet players saying, you're not the fastest, you're not the fastest. And we look to the sentence that we clearly define, we say we're the fastest in the quality league that we're playing. And we consider clearly the others not to be in the league where we are today. Then we are for sure the fastest digital press in that arena.
Can I just make a simple comment on that, Philip? If you're showing that to converters, I suggest you do select some certain label types, because certain of those movable red and blue lines, they do not run at that speed. They only run at that speed if you fill the frame up, and you can never fill the frame up.
Yeah, no, indeed.
And
yeah.
I would suggest it.
Yeah, that is also why I call it. It's a theoretical, but we have some very nice tools for our sales guys. Sometimes you have to make it again. You have to bring things down to the basics and make it simple. So we have some very simple tools that allow them to highlight from that there are other parameters that play part in that as well. Yeah. Now, nice. You have a Cheetah technology. We did a lot of work on it, and fantastic. But what is now the result? I mean, we are now November. Yeah, for November. We introduced her in Label Expo at the beginning of September. Well, so far we sold 8 machines. Apparently, some of them have been sharing that already with some people. But of those 8 machines, 1 is sold in Asia Pacific, 1 is sold in Latin America, 1 is sold in North America, and 5 are sold in Europe, Middle East, Africa. Actually, Europe. But we didn't want to leave out that reason as well. So, and the first 4 will be installed actually in Q1 2015. 2 of them will be in the UK, the other ones will be on the mainland. So that is actually quite impressive. We were quite surprised ourselves to get so fast such a good results. So that's very encouraging, and we look forward to actually 2015. 2015, which we will call also, doesn't matter what the Chinese call it, the year of the cat or the rat or the dog or whatever, we will call next year the year of the cheetah. Where we, one of the first public demonstrations where we'll show the machine again will be around the Xeikon Cafe, taking place in March. You'll hear about it later. We plan also to do an additional press conference before the summer, leading up towards Label Expo. Label Expo is this year quite late. We say that it's September here, but it's actually October, September, when Label Expo is taking place. For sure there, the Cheetah will be there in full glory. And then from there, we work up towards a Drupa. So actually, we're not going to take 12 months, but we do it in, 16 months then almost? 18 months. So it will be a year of 18 months called the Year of the Cheetah, where for sure in the first half of the year here, you will see a lot of communication happening from the new installs that are going to be taking place. People that are very proud also and very eager to communicate about it. That they've invested into the technology itself. So, but this is actually a kind of an update to you to give you some more background on, okay, what is the logic from Xeikon to actually develop a Cheetah? What was actually the effort required for it? What are the advantages for the customer? And what are actually the results that we achieved this year already? And what you can expect from us next year, actually. All right.
Thank you. Any questions?
When is the Cheetah wide, the 508mm? Is that on the plans or?